Hello everyone, welcome to the 20th lecture. Today we are going to solve a numerical problem based on the line canal designing, right? In previous lecture number 19, we have discussed about the line canals and the design steps which we are going to use, which we are going to follow to design a line canal. So today we are going to apply them practically in this numerical problem. So let's start and read out this statement. This statement given to us is saying that we need to design a lined canal. Okay, we need to design a lined canal. Let me take it out and choose this color. Okay, the first thing we need to do is design, right? Design means we need to find out the width of the canal, depth of the canal, and slope of the canal. Got it? So slope, I think it's already given, but we need to find out b and y, width and depth. This is what design means, right? We need to find width and depth of the canal. So we need these parameters. After that we can say that our canal is designed. This is 100 meter per second. 100 meter cube per second discharge. So we need to design, right? The first thing we need to do is we need to design the canal, and the canal is lined canal. Okay, we need to design a lined canal, and the discharge of that canal is going to be 100 meter cube per second is discharge, and then bed slope is given to us 1:2500, and permissible velocity is given to us. The permissible velocity is 2 meter per second. Okay, and what else? We are given with n, value of n. What is n? As we have discussed, n is the roughness coefficient, or we call it mining coefficient, and then side slope is given to us 1.25. This is q, right? Discharge is given to us q. Bed slope is given to us, which is s. Permissible velocity is given to us, which is v, and then we are given with n. This is Manning's coefficient, or we call it roughness coefficient, right? Roughness coefficient. And then side slope is given to us. This 1.25 is horizontal slope, and this represents your vertical slope. Got it? So this is the data given to us. Discharge, bed slope, permissible velocity is given to us, and roughness coefficient is given to us. So as we have discussed in previous lecture, if the permissible velocity is 2 meter per second, what it shows? It shows the material we have used to cover the side slopes and bed of the canal, right? Either it is concrete, it is clay bricks, or boulders, or tiles, or whatever that is. We have values, right? See, in previous lecture we have discussed permissible velocity. If it is given to you, then it's fine. If it is not given to you, we need to take these values. If the canal side slope and bed of the canal is made up of this material, cement concrete, then we will take permissible limit between 2 to 2.5, for burnt clay 1.8, and boulders 1.5. So in our case it is given to us 2 meter cube per second permissible velocity, right? So that means that our canal is going to be constructed using cement concrete. Okay, they haven't mentioned it, but you know from these values that the limit given to us, permissible velocity limit given to us in our problem, is 2 meter per second. That means that the material we are going to use to construct and cover the side slopes and bed of the canal is to be cement concrete, right? So the permissible velocity is given to us 2 meter per second. That means that material to be used will be material to be used for side and bed slope will be concrete. Okay, this means that. So let's start to design the canal and move into the first step. The first step in our designing was to find velocity, right? But velocity is already given to us, so there is no need to find the velocity, and we will move to the second step. What was our second step? Second step was to find out the cross-sectional area. Okay, before that, as we have discussed, that the lined canal can be either in triangular shape, bottom rounded, or it can be trapezoidal shape with corners rounded, right? There are two type of lined canals we have discussed. One is this one. This is trapezoidal with corners round, and this is triangle with bottom round. So let's here assume and solve for trapezoidal section. Start the solution, and we can say that assume a trapezoidal section of canal with round bottom corners. Okay, and let's draw it. It will look like this, right? This one, and its corners are going to be round, something like this. Corners are going to be round. Okay, and then this is the its full supply level. This is full supply level. Okay, and then draw furthermore lines. Let me draw it with red color. We have drawn perpendicular from here to here, right? This is depth of the canal, and this is also depth of the canal. It is represented by y. This is also y, and this distance is also equal to the depth of the canal y, and this distance is also equal to the depth of canal y. Okay, and what else we have derived previously? This distance from here to here, this is going to be our b, width of the canal, which we are supposed to find, right? This is going to be b. Similarly, this is also b, and the side slope given to us, which is 1.25 horizontal, 1.25 horizontal to 1 vertical, right? This is side slope given to us, and bed slope given to us is S is equal to 1:2500. This is given to us. What else? That's fine. So from this, let me mark one more thing. This is 90, right? This angle is 90. We have discussed this figure in our previous lecture. You need to go there and look into it if you haven't listened to that lecture. And this angle is theta. This angle is theta. This is pi by 2 minus theta, and this is pi by 2 minus theta, right? So from this triangle, let me use the same colors and show you again as we have discussed previously too. If you draw this triangle here, this is the blue line, right? And then this is your red line, and then this is your blue line. Got it? What is this red line? Red line is, this is your y, right? This is equal to the depth. And then what is this angle? This angle is pi by 2 minus theta, right? And what else? I think we need to make some changes. Wait. Let me draw it again. Okay, the first line is this one, right? This one, and then red line with this and this, they are making an angle of 90, right? And then this blue line is combining these two lines. It is something like this. So this angle is pi by 2 minus theta. This is equal to y, and this angle is 90, right? So as we have found that we need to find this side, right? And what is this? If we use the trigonometric ratio tan theta, what will be this equal to? Tan theta is equal to perpendicular upon base, right? So in this case, tan theta is going to be equal to, what is our perpendicular? As we know that this side slope is given to us, right? 1 vertical and 1.25 horizontal. Vertical means perpendicular, horizontal means your base. So tan theta will be equal to 1 divided by 1.25. So from this, can we find out the value of theta here, right? Theta is going to be equal to tan inverse 1 divided by 1.25. So theta will be equal to, when you solve it, you will get 38.65 degrees. So write it here, theta is equal to 38.65 degrees. But in our coming calculations, we will need this in the form of radian too. Why? Let me show you. In this equation, you can see, as we have found this, here theta we need to use the angle in degrees, but for this theta we need to put the values in radian. This theta is in radians and this theta is in degrees, so we need the value of angle in both degrees and radian too. So this is in degrees. Now convert this into radian. As we know that 180 degrees is equal to pi radian, right? So 1 degree is going to be equal to pi divided by 180. Okay, and we got 38.65 degrees, right? So 38.65 degrees will be equal to pi divided by 180 multiplied by 38.65, and the answer you will going to get is going to be in radians, which is 0.674 radian. Okay, theta in radian and theta in degrees. So let me highlight it. Theta in degrees and theta in radian. We will need this later on. Got it? So for now that's enough. Let's move to the first step. What was our first step? The first step was to find the velocity, but velocity is already given to us. And after that, our next step is to find Now in this case, the first thing we need to find is cross-sectional area. Cross-sectional area, which is A. And for cross-sectional area, we have formula. What is the formula for cross-sectional area? A is equal to Q divided by V, right? A is equal to Q divided by V. Convert this into blue color. Q divided by V. Okay, this is the formula we got. A is equal to Q divided by V. And we already got the values of Q and V. Q is given to us, which is 100 meter cube per second. The discharge is given to us, and V is given to us permissible velocity, which is 2 meter per second. So the cross-sectional area is going to be 50 meter square, right? This is our cross-sectional area. We got our value of cross-sectional area. Let's move to the next step. In next step, we need to find hydraulic radius, right? We need to find hydraulic radius, which is represented with R, and hydraulic radius, we got formula for hydraulic radius. What was that? For hydraulic radius, we have a formula which is hydraulic radius is equal to area divided by weighted parameter, right? But we have the area, but we don't have the weighted parameter, right? So the problem is here, we need weighted parameter to find out the hydraulic radius using this formula. But we have another formula, another equation where we got R, right? What is that? That is Manning equation. As we know that Manning equation as Manning's equation is equal to V is equal to velocity is equal to 1 divided by N, roughness coefficient, then R raised to the power 2 by 3 and S raised to the power 1 by 2. Okay, so you can notice here we already got the value of V, right? Velocity 2 meter per second. We got the value of N. We got the value of bed slope. So from this equation we can find R, hydraulic radius, right? So we will use this equation to find out the value of hydraulic radius. So let's put the values here. So V is given to us, which is 2 meter per second, which is equal to 1 divided by value of N. Roughness coefficient is given to us. What was that? The roughness coefficient was 0.013. The roughness coefficient is 0.013, then multiply by, we need to find R, right? We don't have the value of R. Then multiply it with bed slope. Bed slope is given to us. Bed slope is 1:2500. The bed slope given to us is value of S 1:2500 power 1 by 2. Now solve this equation for R and you will get the value of R when you calculate it, and R, you will get the value of R 1.482. check it out using your calculator. If it is wrong, then let me know in comments. This is going to be the hydraulic radius Okay, we got these two. And now the next thing is to find the weighted parameter. Weighted parameter, which is P. Okay, as we have mentioned equation for hydraulic radius here, right? This one. Can we use this equation to find out the weighted parameter, because we already got the value of A and R, right? And we will use this equation to find the weighted parameter. So let's use this. R is equal to A divided by P. So for weighted parameter, we know the equation R is equal to cross-sectional area divided by weighted parameter. So it will become P is equal to cross-sectional area divided by hydraulic radius. So P will be equal to cross-sectional area. We got the value of cross-sectional area. What was that? 50 meter squares. 50 meter square divided by R, hydraulic radius 1.482 meters. From this we can get the value of P, weighted parameter. Divide it and you will get the value 33.73 meters. Got it? So this is the value for weighted parameter. Now we need to find out the dimensions. The last step is to find dimensions, means depth and width of canal. Okay, so this is the most important part. We need to find the B and Y, width and depth of the canal. So for that we have discussed two equations, right? In our previous lecture, these two equations. One is this, and one is this. We are going to use these two equations because we already got the value of area and weighted parameter, right? And B and Y are unknown. We already got the value of theta in degrees and theta in radian too. So we will put these values and we are going to solve this equation, and we can get the value of Y and B. So we can say that, as we know that cross-sectional area of a lined canal with trapezoidal shape and its corners, if its corners are round, then the area is going to be equal to by plus y square into cot theta plus theta. One equation is this, right? And for parameter, weighted parameter, we got an equation b plus 2y cot theta plus theta. These were two equations, right? So let's put the values. As we got the value of area already, which is 50 meter square, which is equal to by plus y square into cot theta. As I told you that this is, we need to put the value of this theta in degrees and this theta in radian, right? We already got this value. So the theta we got is, let's put it in degrees. So cot theta will be, cot theta value is 38 point, what was that, 65, right? 38.65 degrees plus this theta in radians. When we converted 38.65 degrees into radian, what was that? The value was 0.674. Okay. Similarly, put the values in this equation. What was the weighted parameter we got? That is this one, right? 33.73 will be equal to b plus 2y into cot theta. Theta is 38.65 and plus theta in radian is 0.674. Put the value of cot 38 here and here, then simplify these equations. When you further simplify this equation after putting the value of cot 38.65 and then add it with 0.674, you will get 50 is equal to by plus 1.924 y square. Okay, and when you simplify this equation, you are going to get 33.73 is equal to b plus 2y into 1.92. Let me multiply this and I will just write down the last equation which I will get. So I need to multiply the equation of cot 38.65 plus 0.674 multiplied by 2. So 2 multiplied by 1.924, you will get 3.848y. Okay, we got two equations. We are doing all this because we need to find out the value of b and y, right? One equation is this, one equation is this, right? Okay, fine. Now we need to put the value of b in equation number 2. Do one more thing. Name this equation number 1 and name it equation number 2. If you solve this for b, this equation will become b is equal to 33.73 minus 3.848y, right? Put this value of b here. Put this value of b in this equation. Okay. And you will get 33. Okay, fine. It's in the form of y square. Okay, there is some mistake, I guess. Let me check it out. by plus, this is one equation, this is fine, and the second equation will be this one, equation 1 minus equation 2. Okay, let's do one more thing. just subtract it and then try to, as you can notice here that this is, here is y square, right? Here is just one y, but in this equation there is no y with b and this y is not square. So what we can do, we can do one thing. Let me show you. Because our end objective is to find value of y and b, right? We can do one thing. Write these two equations here. The first one is 50 is equal to by plus 1.924 y square, right? And the second equation is 33.73 is equal to b plus 3.848 y. Let me multiply this equation with y on both sides. If you multiply it with y, what is going to happen? It will become 33.73y and equal to by plus 3.848 y square. Now we got two more equations. If you further simplify it, it will become okay, let's keep it here and name these equations. This is equation 3 and this is equation number 4. So we will do one thing. We will do equation 1. We need to subtract from equation 3 and equation 4. We need to subtract these two equations. So can I write equation 3 as this? By plus 1.924 y square is equal to 50, right? And then subtract it from next equation, which is by plus 3.848 y square is equal to 33.73 y. Got it? Now just subtract them. When you subtract it, whenever we do the subtraction, the signs actually change, right? This is plus here, it will change into minus, this plus will change into minus, and this plus is going to be minus, right? And this plus is going to be minus. Okay, sorry, this one will not change. The signs of the equation which is at the bottom actually changes, right? This is already plus, so this will change to minus. So let's solve it. This is in plus, this is in minus, we can cancel it out, right? And this will become, when you solve it, subtract 3.848 from 1.924, you will get the answer in minus, which is minus 1.924 y square, and is equal to minus 33.73 y and then plus 50, right? So now this equation, the new equation we got is in terms of y, right? In terms of y. So from here we can find out the value of y. Let's make it more simple and convert it into quadratic form. Can I write it as 1.924 y square minus 33.73 y plus 50 is equal to 0. Okay, now this is in the form of quadratic equation. What was our quadratic equation? Quadratic equation was a x square plus bx plus c is equal to 0, right? If your equation is in this form, that is known as quadratic equation, and in the quadratic equation, to find out the value of this x, we had a formula which is equal to x is equal to minus b plus minus under root 4 b square minus 4ac divided by 2a, right? This is the equation. So in our case, this is a, right? This is b and this is c. Just put into this equation and you will get the desired results. Let's find out the value of y. So to get the value of y, we will use quadratic equation. As we in this case it will become y is equal to b, right? B is minus 33. Here is minus with the formula, and this minus is the sign which is already with 33. So minus into minus 33.73 plus minus under root b square. What is b? B is minus 33.73 its square, and then minus 4ac. Minus 4 into ac. A is 1.924 and c is 50. Okay, then divide it with 2a. 2 into a. What is a? 1.924. when you solve this, you will get two values for y, because there is plus and minus both, right? Once you need to solve it with plus, and in second time you will solve this equation by using subtraction sign. So you are going to get two values of y. One is y is equal to 15.89 meter, and second value you will going to get is y is equal to 1.63 meter. As we have discussed in the numerical in the Kennedy's theory, that if we got two values of y, every time we consider, we adopt the we will adopt smaller value of y. What is y? Y is depth of the canal, right? So we got our depth. The first thing is with us the depth of canal will be 1.63. Now the last thing remaining is we need to find the width of the canal. For width of the canal, we can put this value of y in any of equations above. We already got, for example, let's say equation number 1, this one. Here we can put the value of y, right? And we can get the value of b easily. So let's put what was this equation number 1, right? Let's say we are going to put the value of y in equation number 1, and what it is going to become, put value of y, which is depth of canal, in equation number 1. Okay, what is equation number 1? What was our equation number 1? Our equation number 1 was 50 is equal to b into y plus 1.92 y square, right? This was the equation. So just put the value of y, which I already got, 1.63. So 50 is equal to B into 1.63 plus 1.92 into 1.63 whole square. Solve this for B and you will get the value of B. B is equal to 27.53 meters. Done. That's it. We are done with the designing of canal, lined canal. So let's draw the figure and put the values we got. So we can say that for a canal, for a trapezoidal canal which is round at the bottom, this is round, right? Which is round at the bottom, round at the bottom, and if its side slope is 1 vertical to 1.25 horizontal, and if the discharge we need is 100 meter cube per second, then for that case let me draw this water level first. Then in that case the depth of the canal should be, what should be the depth of the canal and what should be the width of the canal. So the width of the canal should be, we got it here, the width B should be 27.53 meters. B should be equal to 27.53 meters. And what should be the depth? We got the value of depth, right? The depth should be 1.63 meters. 1.63. The depth of canal should be equal to 1.63 meters. And what else? The bed slope, we are already given with the bed slope. The bed slope is equal to, S is equal to 1:2500, and the permissible velocity is given to us, which is 2 meters per second. So that means that we need to do the covering of bed and side slopes with concrete. So this means the bed slope, bed and side slope will be constructed, or you can say cover them with cement concrete. C-E-M-E-N-T, cement concrete. Okay, that's it. So we are done with the designing of the lined canal. Similarly, you can try this same numerical problem by considering the other type of section, which was triangular section, right, with bottom rounded. You can try the same numerical problem for this kind of section. Everything will be same. The only thing you need to change is you need to change these two equations. You need to use these equations for area and perimeter. Okay, here the equations were different, and in this case the equations for area and perimeter are different, so you need to use these two equations to find out the value of b and y. So that's it. We are, I think, almost done with the first part of our course, as our course is irrigation engineering and hydraulic structures, right? So we are almost done with the irrigation engineering part. Soon we are going to start the hydraulic structure part. So that's it. That's it for today. See you guys in next video with our new topic. Till then, goodbye.